is the second video for your question or your math problem solve. So let's look at this one. Shopping cart is given an initial velocity of 3 meters per second as an unknowing adolescent pushed it in the parking lot aiming for the cart rack. And since the rack is downhill, the cart undergoes, or underwent, I suppose I should change that, a constant acceleration of 4 meters per second. The question is, what's the magnitude of the cart's displacement after the first 2 seconds of its motion? Okay, so just to remind you about what we got to do first, I started out that last video with the formulas, but we didn't use them. We're going to use them now. So just remind you, you got to write them down. Final velocity is equal to initial velocity plus acceleration times time. Displacement is equal to v sub naught t plus 1/2 at squared. And v squared equals v subscript naught squared plus 2ax. And then you also need to have your checklist. Okay, so we're going to fill in our stuff that we know. So initial velocity is 3 meters per second. So put that right here. Kind of segregate those formulas. Okay, what else is going on? Acceleration of 4 meters per second. Okay, and they're both in the same direction because it doesn't say otherwise, and there's no difference in the symbol. Like there's no plus and minus. So we assume that they're both plus. And it says, what's the magnitude of the cart's displacement? Okay, oh, we got time there, 2 seconds. And then this is the big question, the displacement. Okay, so we pulled our numbers out of there, and now what we want to do is look at our formulas, because we know that we're looking for this displacement, so we need to make sure that we have that in the formula that we're using. Not in this one, it's in this one, and it's in this one. So then the next thing you want to do is look for the other stuff you have. Well, you don't have final velocity here, so you're not going to be able to use this one independently. And sometimes you have to use one to solve for something, and then sometimes you have to use two. But this one, let's see, we have displacement. That's what we're looking for. We have initial velocity, we have time, and we have acceleration. So this is the one that we're going to look for. And this is kind of the way you want to go through all of your problems, right? Okay, so x equals v sub naught t plus 1/2 at squared. So our displacement is equal to 3 times 2 plus 1/2 times 4 and times 2 squared. That part squared. X then equals 6 plus 8, unless I did the math wrong. So displacement is 14 meters, and it's positive. Okay, so let's do this again. This is getting fun. A skater glides off a frozen pond onto a patch of ground at a speed of 4 meters per second. Here she is slowed at a constant rate of 2 meters per second. How fast is the skater moving when she slid 2 meters across the ground? Okay, so let's see. Her initial speed and velocity and speed are kind of interchangeable. So when they say speed, you can use these formulas too. And we consider this linear because it doesn't tell us anything else. So it's going to be in one line. So keep in mind, if you didn't watch these videos, in all of these formulas, the question to you is, how many directions can you have in each one of these formulas at any time? Yes, that's great. You're right. Two directions, and they're indicated by plus and minus. They're 180 degrees opposite. Okay, so if you don't follow that convention here, or it's not a convention, that rule, you could mess this up. So your initial velocity is 4. your final velocity is what we're looking for, right? Okay. Your acceleration is 2. Do you think it's just 2? Look at that and tell me if you think it's just 2. Well, here's the clue right here. She slowed. So when they said she slowed, if you remember that chart from the PowerPoint yesterday, if acceleration and velocity are in the same direction, that means the speed is going up. So whether they're both positive or both negative, the speed is going up. If one of them is opposite, the speed is going down. So that's something. There's a kind of a big table there, but what you got to remember is that if they're in the same direction, it's speeding up. If either of them, or well, if they're in opposite directions, it's slowing down. So with that said, what do we need to add with our understanding now of the physics part of this? Yes, good job, Logan. A negative, because it's slowing down. So we know it's in the opposite direction because the acceleration is changing the velocity in the opposite direction, which means it's slowing it down. Okay. Oh, and we also have the displacement too. So we're looking for V. What do we have? Okay, so I think we can use this one, right? Because we don't have a time. Could we use any other one? No. So this is the only one that we can use. So V squared equals V subscript naught squared plus 2ax. And what I'm going to do, and I want to strongly encourage you to do, is solve for your variables before you use the formula. It looks like this is already on the right side by itself, so we're good there. So V squared equals 4 squared plus 2 times a negative 2 times 2. So V squared then equals 16 plus negative 8. So V squared equals 8. So V equals the square root of 8. Okay, you want to check my math on that? I don't have an answer key or anything. Make sure that's right. Okay, so, we can't use radicals on our computer at this point, so you're going to have to put it into decimal form. 2.83 meters per second is your final answer. Any questions? Okay, we got another fun question here. Sports car traveling at 50 meters per second slows at a constant rate to stop in 20 seconds. What is the displacement of the sports car in this time interval? Okay, so I'm going to ask Tucker to fill in the formula or the variable list. Yes, very good, Tucker. The initial velocity is 50 meters per second. Okay. Your time is 20 seconds. This is what we're looking for. We don't know the acceleration. So if you look at these formulas here, which one do we get to use? Log or Isabel? Right, we can't use any of the formulas, so we missed something. So the big question is, what did we miss here? We need another number. Good. Yay, you found it. Here's the other number right here. Oh, that's not a number. Well, it's an alphanumeric symbol for a number because it says stop, which means the final velocity is 0 meters per second. Okay, so now what formula can we use? Yeah, I figured it out. It's this one, right? Because we have everything. Oh, no, there's acceleration in that. Oh, no. Because it's asking for displacement. And these all have displacement. No, this one doesn't have displacement. This one does and this one does. But they both have, I think this is a two-step problem. Okay, so we got to find acceleration. So we have two velocities, and so we're going to use this one. Okay, v equals v sum naught plus at. So if you solve for a, it'll look like this. V minus v sum naught divided by a is going to give me time. Oh, shoot. That should be, I wrote that wrong. Sorry, I'm getting late on this video. Should be acceleration. Okay, so 0 minus 50 all divided by 20. Ooh, that's going to give us a negative answer. Should our acceleration be negative? Yeah, it's very good because, thanks Logan, because that's positive and it says it's stopping. So we got to go in the opposite direction. Okay, so negative 50 divided by 20 is our acceleration, 2.5, unless I did that wrong. Anyone else checking me on that? So that's one thing I want you guys to do is check me on that. So there's my acceleration. So now I can, so it's a two-step problem. Now I can use, this one or this one. Either one is fine to find out the displacement. I'm going to use this one though because it's already set up that way. So x equals v naught t plus 1/2 at squared. X equals 50 times 20 plus a negative, actually, 1/2 times 2.5. That's where the negative came from. I took it off of that. Times 20 squared. And my total distance is, calculator kids, what do you got? Yeah, so the answer then is 500 meters. Unless I messed up my math, you can let me know later. Okay, got a couple more questions here. This one says that a soccer ball is moving horizontally at a speed of 15 meters per second. And undergoes a constant acceleration. After 2 seconds, the ball is moving 10 meters per second. What's the ball's displacement? Okay, so it says at a speed. Okay, so that's initial velocity, 15 meters per second. We don't know what the final is. Oh yeah, we do. It's 10. So 10 meters per second. We don't know what the acceleration is or the displacement, but we do know the time. Okay, so we're looking for the displacement, so we got to figure out which formula to use. There's x in this one, there's x in this one. I got my two velocities, no acceleration though. Okay, so this is another one where we're going to have to determine the acceleration. So we're going to have to use this one first, and then we could use either one of these, but I'll use this one because it seems easier. It's already set up. So velocity equals initial velocity plus at, or a equals v minus v sum naught divided by t. A equals 10 minus 15. Oh, so this thing's slowing down. Okay, well, I better get a negative number then for this answer. And it takes 2 seconds. So acceleration here is -5/2, or 2.5 negative meters per second squared. Okay, so now we have our acceleration. I'm going to just plug it into this formula so we can solve for what we're originally going for, our displacement. X is v subscript not t. So we got 15 times 2 plus 1/2 negative 2.5. T squared is 4. I'm just going to put that in there right away. Cancel that out. I got a 2 there. So my displacement is 30 minus 2 times 2.5, 5. our displacement is equal to 25 meters. Okay, our last one example. A kitten pushes a ball of yarn, rolling it at 10 centimeters per second with its nose, displacing the ball of yarn 5 centimeters in the opposite direction. That's an important one. In 2 seconds. What is the acceleration of the ball of yarn? Okay, so what do you think that opposite direction means? Because it's kind of a big deal. Well, it means that the displacement is going to be a negative number, 5 centimeters, because it's in the opposite direction. Okay, so it's kind of a weird question, but yeah, the ball is rolling at 10 centimeters per second, and then the kitten gets it with its nose. There's one of those great drawings. You can totally tell it's a kitten, everybody, right? So it's pushing the ball. So the ball gets here, and I'm assuming that this kitten is stopping the ball because I don't see how else it's going to be able to displace in the opposite direction of 5 centimeters. But it does. So there's quite an acceleration there because it stops it and then it moves it in the opposite direction. So whatever velocity we get should have a negative symbol because it's got to be in the opposite direction of the original velocity. So let's see how this works out. It might be a flawed question. So initial velocity is 10 centimeters per second. Final velocity, we don't know, but I'd like to know. Acceleration is what we're looking for. And the time is 2 seconds. And then our displacement is negative 5. So, yeah, we're going to have to do 2 formulas for this one again, it looks like. So the first thing we're going to have to do is figure out, actually maybe we're okay with this formula because we have our x in there, we have our time in there, we have our v sub naught. So really, that one's going to give us the right answer because we have the acceleration that we're looking for. Okay, so let's plug and chug that away. So x equals v subscript naught t plus 1/2 at squared. So we got to get this a by itself, right? So x minus v sub naught t equals 1/2 at squared. Multiply both sides by 2. 2x minus 2v sub naught t equals at squared. Divide both sides by t squared. A then equals 2 times a negative 5 minus 2 times 10 times 2 all over 4. So A equals, so the acceleration is negative 12.5 centimeters per second squared. Okay, well, I hope these examples help you. Have fun with your assignment.